हॅलो, माझ्या नावाने जॉईन आहे मॅडम. मी रिनेम केलं आता.
Good morning to all participants and today's resource person also, Dr.Manasi Baheti. On the behalf of HRDC, I welcome to today's resource person, Dr. Manasi Baheti, and as well as you all participant also. I want to give a brief introduction of Dr. Manasi Baheti ma'am. She is working as an assistant professor in the Department of Computer Science, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhaji Nagar. She having an 18 years teaching experience as well as an research experience. Her specialization is human computer interaction, pattern recognition, speech processing, and RS GIS. Under her, 5 PhD students are pursuing the PhD degree, and 5 students are doing an MPhil research degree. Welcome, ma'am. And on behalf of HRDC, I welcome to you here for today's session. And madam is going to be delivered the lecture on ANOVA test, one way and two way. So I hope this topic will be very helpful to all the research students to be attentive in the class. And now I hand over the charge to Mansi ma'am. Mansi ma'am, over to you.
Yeah. Thank you so much, Dr. Kaveri madam. First of all, sorry for joining few minutes late. I'm thankful to you for giving me this opportunity. Okay. Shall we start?
Yes, ma'am.
Okay. Yeah. Okay. So good morning, all students or participants rather. I am sure that you are past some days while doing this course, you might be knowing some background knowledge regarding all these research methodology tests that we conduct on various data sets as per our requirement or as per in which area we are working and what is our area of interest. So not all the tests everyone will implement, but we must to have a basic knowledge and understanding or at least overview of how many tests are there and in which situation we use which test. So I know that depending upon our compatibility, depending upon our data set and depending upon our objective, we apply many tests using various techniques or we using various tools. But there are some basic tests used in research methodology which are very important, and some are having statistical background and some are having just a background regarding with respect to or they are very specific to your data set or your objective. So some common tests which are considered as the standard in research methodology, which are having from the statistical background, the overview and some just I will quickly take the overview of this test. Right, you might be knowing that there are some standard measures in statistics, like measure of central tendency is there, measure of dispersion is there, measure of asymmetry is there. You might be knowing all these tests, right? And the importance of that. So in order to have a normalized or standard database or standard tools and technique, or to provide some standard conclusions based upon our experiment, we need to implement these tests, right? So there are some univariate techniques. Univariate means what? Only one variable output variable will be there. So these techniques are roughly classified as parametric test and non-parametric test. You might be aware of this, right? So I hope I'm audible. There is no disturbance.
Ma'am, sorry for disturbance. Ma'am, you are not visible. Are you sharing your PPT or what?
No, right now I'm not sharing. I'm just talking to you. In few minutes, I'll be sharing that.
Okay, okay, ma'am. That
Yeah,
just
ma'am. Your voice is clear, ma'am. Thank you.
Okay, thank you so much. Yeah. So univariate techniques means what? Only one dependent variable we are having or only one output variable we are having. So these univariate techniques are divided roughly into parametric tests and non-parametric tests. हे बहुतेक तुम्हाला माहित असेल, right? So in parametric test, what we do? We do quantitative analysis. Quantity is very important in parametric test because we consider some parameters. Parameters means is nothing like characteristics or feature of something, right? So we consider some parameter, we go on doing the test, and we reach to some quantitative data or quantitative value. That is all about the parametric test. Okay. On the other hand, in non-parametric tests, we are not considering direct some parameters. So these are the qualitative test, non-parametric, right? So parametric and non-parametric, these are the two basic types of tests. So our focus of interest today is parametric test, right? There are many tests, as I said earlier, depending upon your sample size, depending upon your what kind of data you are handling, and what is your objective, you will select the appropriate test. For example, in parametric test, the famous tests are Z test. So Z test when we use when we are having large population and the sample size is greater than 30. So in that case, we go for the Z test. Okay, normally when we are pursuing PhD, we obviously we are going to consider the large data sets, right? So Z test is quite frequently used. Another is t-test, which is also called as student test. So in that case, when small population we are having or the sample size is less than 0, in that case, t-test or famously known as student's test will be used. Okay, the third test, which is our topic today, which is the important test in the parametric parametric view, is the ANOVA, or it is also called as the F test. So Z test, T test, and F test. These are three important tests which are conducted under the parametric tests. So F test is also called as famous name of F test is ANOVA, that is analysis of variance, which we are going to cover today. So as we have seen that Z test is used when we are having large population or when sample size is greater than 30, and T test or student test is considered when we are having small population or the sample size is less than 30. But when ANOVA is used, ANOVA, in the case of ANOVA, sample size does not matter. Okay, sample size can be of any size. It can be small or it can be large, means the population can be small or large, the sample size can be small or large. What ANOVA or F test does is it compares more than two groups, or it compares the variances of two or more groups. Okay, that is what ANOVA actually does. So here today we are going to learn ANOVA, which is the type of parametric test in which we are dealing with the quantitative data and not the qualitative data. Okay, so with this, I'll share my screen now. Please let me know if my screen is visible, the PowerPoint presentation is visible or not.
Yes, yes.
Yes,
Ma'am.
ma'am.
So, ANOVA?
Yes, ma'am. We can see your
Yes.
presentation, ma'am.
Yeah, thank you so much. See, because I'm doing it from the same laptop. So when I'm sharing my PowerPoint, I'm not able to see the Zoom platform. That's the reason I asked. Okay, so ANOVA, as you can see, is analysis of variance. Okay, I hope you know what a variance is. So ANOVA is most useful when conducting the experiments. Okay, so ANOVA is right. I hope you are knowing what a variance is. I hope you are knowing. In the earlier I have told that there are in statistics there are some measures, like measure of central tendency, under which we give mean, mode, and median. Okay, mean, mode, median are the central tendency. What do you mean by central tendency? Means if we are having huge data, but we describe that data using only one point, that is central tendency. Like while doing your graduation or post graduation, you are having suppose 6 semesters. So you will tell the grand total of your semester. So grand total is nothing but what mean or central tendency. Means you don't, you will not explain marks of each and every semesters, right? You will take average of average, and that will be the grand total. Okay, so that is the central tendency. Mean, mode, median, we can uh, declare. Another is measure of dispersion, that is variance and standard deviation. So we are here area, our concern is to the variance and standard deviation. So variance means what? Variability. Variability means what? We are finding the differences. How your data is dispersed, or how, what is the spread of your data across the mean. Means suppose you are having some data, you have computed the mean, and from that mean you are trying to find out how your data is spread across the mean पासून तुमचा डेटा कसा कसा कोणत्या डायरेक्शनला कसा कसा स्प्रेड झालेला आहे, that you want to check with the help of the variance, right? So I hope variance is clear to you. Variance is a very important measure of dispersion, right? Variance and standard deviation and range, these three are measure of dispersion. So standard deviation will give you how your data is deviated from the mean. Okay, so we ANOVA study mainly, suppose you are having more than 2 or more than 3 groups, you are having mean of all these groups. So now you want to study how these 3 groups are different from each other. That study using ANOVA you can do. One important thing is there in while doing the ANOVA is the knowledge of hypothesis. I hope as we all are PhD students, then you might be having the knowledge of hypothesis, like hypothesis and null hypothesis, right? Is it okay? I hope you are knowing the concept of hypothesis and null hypothesis. Hello?
Yes, ma'am.
Yes,
Yeah.
ma'am. Yes, we know it.
Hypothesis is nothing but a claim that we are doing. Like before starting the research, we do the hypothesis. Like this is our claim, and throughout the research, you have to keep going on the implementing the procedures that will, at the end, will prove your claim. Okay, so that is nothing but a hypothesis technique, testing. So what ANOVA, how ANOVA is related with this hypothesis technique? Hypothesis is also called as a test of significance, right? So it is a formal procedure for comparing observed data with the claim, right? So analysis of variance is hypothesis testing procedure that is used to evaluate differences between 2 or more samples, right? So it permits the it permits analysis of it means what we do the analysis of several variables at the same time, right? It gives greater flexibility in designing our experiments. We can make multiple comparisons with only one test, that is ANOVA, right? In short, we can say that ANOVA is a tool for analysis of the data, right? So analysis of variance, in order to make a confident and reliable decision, we will need the evidence to support our approach. Okay, so that is where ANOVA comes into the picture. So suppose we are having 3 groups. We have taken the mean of every group. Now we will compare all these groups using some parameters, right? So while doing the ANOVA test, we have to consider some parameters like sum of square, mean square, F value, F critical value, P value. All these things are considered while conducting actual the ANOVA test. So all these parameters will check the difference between the groups so that we can reach to our some conclusion, like shall either we support the null hypothesis or we have to reject the null hypothesis. So to support the hypothesis strongly, ANOVA test is conducted or computed. So the result of ANOVA will strongly help you to decide whether to go with the null hypothesis or to reject the null hypothesis. As you can see the picture, there are different bell-shaped curves. And I hope you all will agree that these are the bell-shaped curve of different distributions. This is nothing but a distribution. See, if we are plotting a graph of something and we are getting a normal bell-shaped curve, that is called as the normal distribution. But in this picture, we can see that the bell-shaped curve is having different shapes. It is not perfectly bell-shaped or it is not perfectly symmetrical. Okay, first picture is like it is highly kurtosist. It is having the high peak. It is not a perfect bell shape. The middle picture is the flattened. That is, it is the low kurtosis. It is also measure of statistics. And the third one is like the normal distribution. That is the bell shape curve. So ANOVA will find out the difference between all these different distributions. Okay, every group is having different distribution, and ANOVA will compare all these distributions. As earlier discussed, I hope you all are very well aware of actually what a variance is, but quickly we will revise here. So understanding variance, variance measures the variability from the average or mean. Like variance is a measurement of spread between numbers of the data set. Okay, for example, suppose throughout my semester, I conduct 3 unit tests, unit test 1, unit test 2, and unit test 3. So while conducting these 3 tests, what is the result of every unit test? I will plot a distribution curve of every test, and then I will try to find out whether students are improving in each test or not. Okay. After, if I compare the result of all these 3 unit tests, 1, 2, 3, then I can apply the ANOVA test and see whether students are improving or not. Okay. Or if they are not improving, so what is the significant difference, or what are the significant reasons behind it that I can that I can decide in my conclusion. Okay, so variance will give me the differences among the data. So that's the reason variance is very important here. Another measure of dispersion is the standard deviation. The square root of the variance is the standard deviation, right? Why we are taking square root? Because many times we want to discard the units label. Unit आपल्याला नको असेल, then we take the square root of the variance and we call it as the standard deviation. Most of the time, standard deviation is preferred over the variance. So this is the variance in short, a measurement of how far each number in the data set is from the mean average. Okay, so again, ANOVA is used to check if means of 2 or more groups are significantly different from each other. So if we are having small samples, then t-test will be very beneficial. But if we are having large data set, then ANOVA will give us more better results that t-test cannot handle. One very important part that ANOVA does is means t-test kadi karto apan when we are having small data set, right? Sample size is very small, that is less than 30. And t-test also does not compares the group. ANOVA test is having a very important feature that gives its power to actually find out the differences. Okay, how it compares the group? By two way it compares. These are two very powerful technique to compare the groups. One is between the group variability and another is within the group variability. Okay, so between the group variability means what? Between the group and within the group, I'm sorry. So between the group means suppose I'm having 1, 2, and 3 groups, like class unit test 1, unit test 2, and unit test 3. So I can compare between first and second group, between second and third group, and between first and third group. That is between the group variability. Okay, but within the group variability means what? Suppose class test 1 I will consider, only first class test I will consider. So within the result of only class test 1 I will consider, and I will compare the result of that group only. I will compare the result of the students between that group only. Okay, so within the group variability occurs when there are variations in the sample distribution within the single group. Okay, so only first group I will take, and I will compare the result of each and every student in that group only. That is the within the group variability. So these two techniques are considered as most powerful in the ANOVA while giving the concluding remark in the ANOVA test. So this is very important, group variability between the group and within the group. If you see, look at the picture. So analysis of variance test whether there are statistically significant differences between three or more samples, right? Next, the outcome of ANOVA is the F statistics. It is also called as F test that we have seen. Why it is called as the F stat? F test or F statistics. F is nothing but it gives the ratio. Just we have seen what do you mean by group variability. So F statistics finds out the ratio of group variability between the group and within the group. Okay, so this ratio will give us the concluding remark of the ANOVA test. So that's the reason it is called as the F statistics, because F is nothing but the ratio of variability between the group divided by within the group. So depending upon this, the null hypothesis will be supported or it will be rejected. So look at the picture here. We are having group 1, 2, and 3, and group 1, 2, 3 we are having, and the below that you can see the three groups. We are proposing the null hypothesis. If there are no differences in the population between the means of the individual group, so you can see the middle figure. We are having all groups in the same line. Okay, that is the null hypothesis. Along with this, we will also put the alternative hypothesis. So at least two groups means differ from each other in the population. Okay, so two group means differ from each other in the population. So we can see in the last figure that the coefficients of the three groups are not in the one line. They are placed at the different locations. Okay, so that is the alternative hypothesis. Now, going much deeper of this group variability concept, look at the first figure. So if our one criteria here is salary, right? So on this we have to what you call we have to do the study of three groups, group 1, 2, and 3, what their salary income is. So as you can observe first figure, we can see there are three different groups, like group 1 green, group 2 brown, and group 3 yellow. So variance within the group, when it comes to variance within the group, it is very small, because if you look at within the group, I am saying, look at the green group of the people, they are very closely put together, so there is no much variance among them. So variance within the group is very small in the first picture. Same for the group 2, which is shown brown color people, and group 3 yellow color people. So all these groups are very closely put together. They don't have much difference among them. Okay, so within the group variability is very small, but variance between the group is very larger, because clearly we can identify three groups because they are having some distance between them, right? So variance between the group here is the large, and variance within the group here is very small, that we can clearly identify from this figure. On the other hand, the second figure is a little bit complex. We can observe from the color. Group 1 green people color, we can have the variance within the group is large. Okay, in the first figure, all the persons are put together, they are very closely coupled together. But in the second figure, the variance within the group is very large, because you can see all the figures are not closely put together as figure 1. They are dispersed from each other. So that is the variance within the group is very large here. So brown group and yellow group, they all are at some distance from each other. So variability within the group is large here. Okay, but variability between the group is small. we cannot clearly identify as we do in the first figure. In first figure, we can clearly identify three groups, not only because they were having different colors, but we can have a vision that they are separately put together. But in second figure, if the colors would not have been different, it would be difficult for us to identify whether they belong to different group or same group. So variance between the group here is the small, right? We can see. So this group variability is what you call it is a key point. Hello, yes.
Ma'am, your voice is not
What
properly
Coming. Hello.
Hello.
your voice breathing, ma'am?
My voice is breaking. Uh, Joining from Wi-Fi, okay, I'll be a bit louder. Okay. So this figure is why
No,
it's important.
technical problem, ma'am.
Okay. If it is not coming properly. Hello. Voice is not clear, ma'am. Hello. Okay, I'll be a bit louder. Okay, thanks for informing me. See, group
Get
variability
ma'am.
in ANOVA test, group variability plays very important role because it is the main factor that affects the direct result of the ANOVA test, right? So variance within the group in first figure is very small, we can clearly identify, and in the second group it is very large. Okay, do you understand this figure, second figure? Please let me know. Second figure, it is clear, or shall I repeat?
Yes, ma'am, it's clear.
Okay. Okay. So in second figure, we can clearly see that variance within the group is very large and variance between the group is very small. तिन्ही group थोडेसे एकत्रित झाल्यासारखे दिसत आहेत. So variance between the group is very small here, right? Why I am repeating this is because group variability is the only key factor that gives the concluding remark or that affects the result of the ANOVA test, right? So in basic ANOVA situation, two variables, one categorical and one quantitative variable. Okay, it is also called as the factors. Now, what a factor is? Factor is nothing but the categorical variable. Okay, in the basic ANOVA situation, as you can see, first is categorical and another is quantitative variable. Do you know the correlation? In correlation, you might have seen that independent variable and dependent variables are there. Okay. So categorical variable here is independent variable and quantitative variable is the depending variable here. Okay. So these two variables are considered in the ANOVA test. Yeah, these are some important terms in the ANOVA. Dependent variable, the item being measured, जो output असेल that is nothing but the dependent variable which is influenced or affected by the independent variable. For example, suppose my salary depends upon my experience, number of years of experience. So my salary is the dependent variable and independent variable is number of experience. Okay. Independent variable, these are the items being measured that may have an effect on the dependent variable. So dependent variable is influenced by the independent variable, right? Suppose null hypothesis, this is when there is no difference between the group or means. And alternative hypothesis, there is a difference between groups and means. I'm sorry. Last important term is factors and levels. So independent variable is called a factor. Now what a factor is actually, factor is nothing but a categorical variable. For example, gender of the person is suppose male or female. Suppose my result is pass or fail. So these are the categories, right? We can clearly identify pass or fail, yes or no. Okay, so this is the category. So category highly affects the dependent variable. Okay. So basically, ANOVA is conducted in two ways. That is one-way ANOVA and two-way ANOVA. The difference is very simple. In one-way ANOVA, we consider only one independent variable and one dependent variable. Okay, both the variables are 1, 1. That is simple, the one-way ANOVA. Okay. In two-way ANOVA, a dependent variable is only one, but the independent variable are two. For example, in one-way ANOVA, suppose my happiness depends upon my salary, right? So happiness is dependent upon salary. So happiness is the dependent variable and salary is the independent variable. दोन्हीकडे एक एकच variable आहे. Independent variable is one and dependent variable is also one. On the other hand, in the two-way ANOVA, suppose my salary depends upon my education and number of years of experience. Okay, so my salary depends upon two variables, not only one variable, right? So dependent variable is dependent on the two independent variable, right? So that is the two-way ANOVA. So once again, in one-way ANOVA, only one independent variable and only one dependent variable. In two-way ANOVA, one dependent variable, that is output is only one, but input are more than one, that is two. So my output depends upon two factors or two variables, right? That is the simple two-way ANOVA. So one-way ANOVA, the most common method of performing the ANOVA test is one-way. The one-way ANOVA means that the analysis of variance has only one independent variable. It is also called as one-factor ANOVA or two-factor ANOVA. On the other hand, the two-way analysis of variance is a variations of the one-way analysis, right? There are two independent variables in this equation, hence the name is two-way or two factors ANOVA. I hope this classification is clear, one way and two way. My voice is coming now clearly.
Yes, ma'am.
Okay, thank
Yes.
you.
Yes, ma'am. Yes, ma'am.
Yeah, thank you. Okay, before going directly to the applications now, we will take some examples over here. Okay, group variability is clear to you. What is that and how it is important?
Yes.
Okay. So what happens in actually ANOVA applications like other tests, Z test or T test, it is not directly considering the sample size because it is not working on the sample directly. ANOVA works on the group. Okay, already we have taken samples from the population, we have formed the groups, and we are taking mean of the group, and we are simply comparing the mean from of the two or more groups. That is the only work of the ANOVA. Now, with the help of some examples, we'll see. Like ANOVA is having applications in each and every field. Like you can see in agriculture, suppose a farmer wants to compare the yields of three different maize kinds. He grows each kind in a separate area and measure the yield at the harvest. Okay, तीन प्रकारचे वाण त्यांनी लावलेले सपोज मक्याचे आणि तीन ठिकाणी त्यांनी ऑब्झर्वेशन केलं शेतकऱ्यांनी and finally he will apply the ANOVA to decide which kind of yield was more efficient at the harvest time. Okay, so agriculture nowadays in in persistent agriculture, we are using the these techniques actually on the yield at the harvest to analyze the outcome of the crop. Okay, second is a researcher wants to know the impact of various fertilizers on the development of the tomatoes. So he assists different fertilizers to different groups of the plants, then measures the plant's height after the set period. See, applications आपल्याला खूप बघता येतील. The thing is that when ANOVA is applied on the very huge data sets. Number one, and number second, on the for it is observed for the some period of the time or for the duration of the time. Okay, so that is the main characteristics of ANOVA, that it is able to handle a huge number of data, and it is able to handle the data which is observed some time series or over some duration of the time the data is taken. So in both of these cases, ANOVA will not fail to give the result. It will be rather it will give you more accurate predictions that you can take into the decision for the next crop. Okay, so that is the beauty of the ANOVA. At every sector, it is having the use. Okay, just a second. By mistake, I have stopped my presentation. I will share it again. I hope my screen is not visible to you.
No, ma'am.
Yes,
No,
ma'am.
ma'am.
Not visible.
Yeah. I am sharing it. Okay. Any doubt until this? Am I clear? Means, are there any ambiguities in my delivery?
No, ma'am.
Is it clear?
Yes, ma'am. Yes, it's
Means you
clear.
can ask question if you are having any.
No.
Okay, tell me how are you using any tool for conducting test yet? Means this is your starting position of your research, or you are already started the research? Means are you using some
Starting position.
SPSS? Sorry.
Starting position.
Okay, so are you any one of you is using SPSS or R tool or any other tool for doing this?
No, not yet.
Okay, good. Just a second, I'm sharing my screen again.
Ma'am, can't see the screen, please. Hello, Mansi ma'am. Hello, anyone is there online?
Wait, sir. Ma'am is sharing.
Hello. Hello.
Hello.
Hello.
Yes, ma'am.
Yes, ma'am.
Yes, I got disconnected and मला कळालं नाही. I was talking. I'm sorry for that. I got a call, then I realized that I was disconnected. Okay.
Oh,
Sharing the screen again. I hope screen is visible.
yes,
We are
ma'am.
ma'am.
looking
Yes,
at the
ma'am.
application.
Yes,
Okay,
ma'am.
now we'll go some little bit fast. In education, as I have given you the example, suppose a teacher wants to compare the performance of student from two totally different courses, also, or from the test or assignment conducted, we can also apply the test. Okay. Or suppose right from your after your pre-PhD coursework is over, we can apply the ANOVA test on all your performance, like different faculties like science and technology, humanities, and commerce and management. So we can apply the ANOVA test and find out what exactly learning outcomes are from these three different faculties of the pre-PhD coursework candidates, right? So the thing is, remember, whenever you are conducting ANOVA, now, remember that you can handle very huge data. You can handle the data over some period of time. That is very important feature, which we cannot have in other tests, right? So ANOVA is very powerful in that way. And the thing is, after applying the ANOVA, we can clearly take some conclusions, or based on these conclusions, we are able to take some decisions or do some predictions to take what will be our further strategy, right? So ANOVA is very useful in almost each and every field. In medicine, okay, before 3 or 4 years ago, we all have witnessed the COVID pandemic, right? So after COVID pandemic, what we were doing? We were doing the vaccination, right? Covishield, or what was other that? One was Covishield and another was another, one more vaccine was there, right? So two vaccine, ह्या दोन vaccine कशा आल्या market मध्ये? So one vaccine was claiming that after we did the vaccination with this, we will get 95% protection from the COVID. Another vaccine was claiming that after, if you do the vaccination with their vaccine, you will get 75% protection from the COVID, right? So how what was their claim and how they were claiming that percentage? So they performed the test of their vaccines on some respective group of people, and after observing the people for some period of time, they came to know about the percentage of protection from the COVID. One vaccine was claiming to have 95% protection, another was claiming 75% of protection, right? So how do they come with the claim? They come with the claim after performing the ANOVA test on some group of people. So ANOVA test is very popularly or very largely performed in the pharmaceutical companies. Okay, pharmaceutical company always prefer to perform the ANOVA test on some group of people. They observe the group of people for some amount of time, and they come with the conclusion like 75% protection or 95% protection. So whenever pharmaceutical companies are bringing any drugs into the market, they perform a very rigorous ANOVA test on the group of people. Actually, they are doing this, pharmaceutical company, right? Second, a very important field where ANOVA tests are used very rigorously is the by the group of psychologists. Okay, psychology च्या field मध्ये सुद्धा what they do, they suppose they want to find out the effect of good sleep on the human health, or effect of good sleep on your psychology. Okay, so they will actually form a large group of people, and for 3 months or 6 months, they will observe the people sleep and their behavior, and they will apply the ANOVA test on the data collected, and then they will come up with some conclusion, or they will predict something. Okay, so ANOVA test is very heavily used in the pharmaceutical companies, and by the psychologist doctors on team of psychologists. Okay. Social sciences also, if they want to do some survey, then from that survey, they will apply some ANOVA test on the inputs given from the survey, and they will come up with the conclusion. So in social science, as you can see, sociologist wants to compare the views of individuals from various socioeconomic background. Then people will be interviewed. जसं मी म्हटलं की सर्वे केला जाईल लोकांचा, and from their opinion, ANOVA test will be fired on this data set. Okay. See, examples are many. The thing is that you should remember that what is the power of ANOVA, or what is the importance of ANOVA, that it gives the group variability. ओके. त्या ग्रुप मधल्या लोकांमध्ये पण कंपॅरिझन करता, एकाच ग्रुप मधल्या लोकांमध्ये अंतर्गत कंपॅरिझन करता येतं, आणि 2 किंवा 3 ग्रुप असतील तर त्या ग्रुपमध्ये सुद्धा कंपॅरिझन करता येतं. सो ग्रुप व्हेरिएबिलिटी इज द मोस्ट पॉवरफुल टेक्निक ऑफ द ANOVA. Second, it can handle huge data and large number of time also it can handle. So that is the main features of the ANOVA. Okay. So here is another example. You're a social researcher interested in the relationship between income and happiness. So you survey 500 people whose income range from $15,000 to $75,000, and ask them to rank their happiness on the scale of 1 to 10. Okay, so your independent variable income and dependent variable happiness are both quantitative. So you can do a regression analysis also. Okay, so yeah, as you are people from, most of the people are from commerce and management background. So you will be aware of the regression analysis also, right? So many times what happens, ANOVA and regression are confused together. Okay, both the techniques are very powerful. Both the techniques are very heavily used in every field, like research, medicine, business, corporation, e-commerce, everywhere this is used. And both are used on large amount of data. Okay, but there is slightly difference between the regression and analysis. So before we go and take actual example in the Excel, we'll quickly see the difference between ANOVA and regression. Okay, so both are the statistical methods. Okay, but what regression does, it finds out the relationship between two variables. Okay, how strong the relationship is, and from that relationship, how many data points belong to one line. So regression draws a line in the graph. Okay, and how many data points are part of this line, that regression finds out. Okay, on the other hand, ANOVA, what it does, ANOVA compares the groups. Okay, simply मोठे मोठे ग्रुप जे असतात ऑलरेडी फॉर्म केलेले, ऑफ विच वी नो द मीन, मोड, मीडियन, स्टँडर्ड डेविएशन, variance we know, it will just compare the groups. Okay, ANOVA. And regression, what it will consider only one group, and it will try to find out, it will try to study the variables, dependent and independent variable. ह्या दोघांमधला काय संबंध आहे, that it will find out, it will study in the regression. So regression is different and ANOVA is different. Okay, regression is taking only one group, and त्या group मधले variables काय आहेत. Only that is the point of focus of the regression. In addition to this, regression is used to find out the missing values in the group. And not only this, regression can be used to find out the future values also. Okay, for example, a student is continuously getting 8 marks, 6 marks, and 7 marks in the class test of marks 10. Out of 10, the student is getting 6 marks, 5 marks, or 7 marks. Okay, so we can predict in the coming test how much marks that student will be getting, will be scoring. So that regression will tell you. But ANOVA, ANOVA will not study the only one student. ANOVA will study the group of students, and not only one group, it will study the more than 2 groups. Okay, so both, what is similarity? Regression and ANOVA are both the statistical tools. Number one, both are very useful. Both are very highly used in all sectors in real life also, but they are having some difference. Okay, so regression and ANOVA need not to be considered as the same. Okay, now as I have told you that while doing the actual research, we use many tools. Okay, here I will show you the simple example of how ANOVA test can be used in the Excel. We can use SPSS also. Basically, statistic people, they go for the SPSS, the licensed software, and the open source software is also there, R tool. बऱ्याच जणांना तुमच्यापैकी माहित असेल. So using SPSS or R tool also we can perform all the test. But the simple way I'll show you, using the Excel also we can do the same things. Okay. मग if you consider same data, if you take same data वर जर का आपण R मध्ये काम केलं, ANOVA फाइंड आउट करण्याचं आणि एक्सेल मध्ये फाइंड आउट करण्याचं काम केलं, सो थोडस तुम्हाला रिझल्ट मध्ये व्हेरियन्स दिसेल. फार काही फरक नाही दिसणार, पण थोडस. वाय? बिकॉज the method that Excel is applying and R tools are applying are slightly different. So small variations you can have. Okay, but there will be no major difference between the results. Either you do in Excel or you do in R2. Okay, Excel gives you excellent, very simple, user-friendly way to find out the ANOVA. And not only this, at the end, Excel gives you a summary table of the ANOVA test. Okay, we will see. Okay, so here are in Excel you have to install the data analysis tool pack as an add-in. Okay, how to do that I will show you. So here are the steps. I will share this PPT with you. So choose the file and then option. So in the Excel options window, choose add-ins. Next, to manage, select add-ins. Okay, instead of reading, I'll just go to the Excel now. Just let me know whether it is visible or not. Okay, I'll go to new one. Okay, is my Excel visible to you all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so just go to the file menu. In that you will have here Excel option. Now, has your interfaces, it will be different, little bit different as per your version of the MS Office that you are using on your systems or laptop. So here, go to the file, go to the options. कधी कधी नुसतं option दिसेल तुम्हाला, but here you can see the Excel option. Click on the Excel option, and to the left side, click on the add-ins. After clicking add-ins, you can see that, just a second. इथं खाली Excel add-in दिसते, and just click on the go. Is it visible? Because on my screen it is hiding behind the zoom buttons.
It's
This
visible, ma'am.
Yes, ma'am.
Yeah,
Visible.
okay. So Excel add-ins,
One
if
time,
it is
this
not
time.
selected, you have to select the Excel add-ins and then just hit the go button. A pop-up window will appear. In that you have to see, I have already installed, so it is showing you as the selected. You have to select this analysis tool pack and click OK. Okay. Now what you have to do, from this table, go to the data. Go to the data menu. On the data menu, to the right hand top corner, you will see the data analysis. Okay, just click there. A pop-up window will appear. Here you can see there are various tests of the statistics, like ANOVA. Starting from ANOVA, they are having two-factor, with replication, without replication, then correlation, covariance you can find out. You can do this descriptive statistics also. Okay, you can find out the F test for sample 2 variables, Fourier analysis, histogram. So regression, sampling, T test, Z test, all of the tests you can do here simply. Now, how to do that? We'll just take an example over here. Okay, book 1, what I did here is, see here simply I have taken group 1, group 2 and group 3, right? Randomly I have put 10 values in each group. Group 1 is having 10 value, 2 is having 10 value, and 3 is having 10 value. Randomly I have put here value. I know these values are very small, but we'll just see how to apply the ANOVA on this value. So we are having 3 groups here. We can increase the values also, right here. Or we can increase the group also, like group 4 we can have, or we can, instead of having 10 values in each group, we can increase the values also. Okay, we can put it 50, 100, large number of values also, because actually in real applications, ANOVA don't take such a very small values like 10 on this. It takes large number of groups, right? because for such a small value, t-test would be very sufficient. Okay, now what you go to data analysis tool pack. Then for here, ANOVA single factor. Okay, it is already selected by default, and click here OK. So a window will come. Here you have to give the input range. Means what? Input आपल्याला कोणते values घ्यायच्या ती range आपल्याला इथे द्यायची. So already I will select this. Okay, then group by columns or rows. So we are grouping it by column by default. Okay, this is very important. Ata when we are doing the ANOVA test, where you want the output result तुम्हाला कुठे पाहिजे. So here you can have the three options. Output range in the same sheet we are working. We can select the output range, or in the new workbook or new worksheet. So I am selecting the new worksheet. So I am clicking here OK button. So immediately a new worksheet. I'm directed to the new worksheet here. Okay, I'll make it little bit large. ANOVA single factor. The test name is ANOVA single factor, right? You can see ANOVA single factor. Here is the summary. The first table, you can see there are two tables. This is the actual result of the ANOVA one way. You can see a very click of within a fraction of second and within a very few clicks, you can see the ANOVA test result. Very simple. Just select the group, and click select the ANOVA single factor, and you will be having the result. That is very simple. So in the result, you can see there are two tables. First table is very important. It gives you the central tendency and variance also. Okay. So group 1, 2, 3. Count काय प्रत्येक group मध्ये. Sum काय आहे. Sum means what? Suppose you are having this group. Okay. So the number of data items in each group त्याची sum घेतलेली आहे. Then average of each group is taken and variance of each group is taken. Okay, so that is the basic calculations of each group. Count is there, sum is there, average is there, and variance of each group is taken. Then the second table is actually giving you some values. This is called as the summary table of the ANOVA, right? So we will study this table. I'll just a second. I want to make it somehow large. Okay, I hope now it is visible. So source of, let us go to the first column, source of variation. So between the group and within the group. जे variations कुठून कुठून काढलेले आहेत, तर between the group काढलेले आहेत आणि within the group काढलेले आहेत. Okay, the second column is SS. So SS stands for the sum of squares. Okay, it is sum of squares. Means what? Sum of squares is nothing but the when we are considering data points. Suppose between the group it is taking. So दोन्ही group मधले difference काढेल तो. Okay, it will take the difference. Now difference कसा घेतात? Simply by subtracting the data items. Okay, and sum of squares म्हणजे काय? आधी त्याचा difference काढला जाईल आणि मग त्याचा square केला जाईल. So why it is taking square? Because जेव्हा पण आपण calculations करतो, if we are having, sometimes we can have positive values and sometimes we can have negative values also. Okay, suppose I am doing -8. Suppose I am doing -8 -8 plus 2. Okay, or -8 plus 3. So answer is -5. So sometimes in calculations I can have positive values and I can have negative values. So to eliminate the negative values, आपल्याला negative value नको आहे. So to eliminate the negative values, the square is taken. तो जो difference येतोय, जी वजाबाकी येते त्याचा square घेतला जातो. So that is nothing but the sum of squares. Okay, so the second column gives you the sum of square of the between the groups and within the groups. Okay, second is the DF, that is degree of freedom. Degree of, we'll see it later, degree of freedom. Say third column is the mean square. Okay, mean square प्रत्येक square जे sum of square घेतलं त्याचा mean काढलेला आहे. Then is F factor. Okay, then is P value and F critical value. What these actual values are? Okay, I'll open a file here so that just a second. I have opened a file for you here. Okay, is a file visible to you?
Yes, ma'am.
How to interpret the ANOVA table? That is nothing but a summary table at the end. So ANOVA involves calculations and interpretations of some number of parameters because it is parametric test. Okay, let us see here. So source of variation is between the group and within the group. Sum of squares, that is SS, degree of freedom, mean square MS, and F factor. Okay, so what actually is this? I'll just scroll down. Sum of square is nothing but calculated by adding a series of squared error terms, okay, within the group and between the group. Square is simply taken to eliminate the negative values or the value which are having the minus signs. Okay, so for one way ANOVA in the table 1, the total number of data point is n and the number of groups of is k. So degree of freedom कशी काढली जाते की जेवढे डेटा पॉइंट आहेत म्हणजे n आणि जेवढे ग्रुप आहेत त्यांची वजा त्याच्यातून मायनस केलं जातं. लाईक डिग्री ऑफ फ्रीडम इज n-1. म्हणजे नंबर ऑफ डेटा पॉइंट सपोज 10 आहेत आपल्याकडे, त्याच्यामधून नंबर ऑफ ग्रुप्स मायनस केले आपण. ओके, सो n-1 is considered as the degree of freedom. Sorry, n-1 is number of data points minus 1 and the k is different groups, so k-1. So these two values are considered n-1. आपल्या केसमध्ये 10-1 येईल आणि k-1 means we are having total number of groups as 3. So 3-1 will be the degree of freedom. Now why we need this? Because we are comparing the groups. So while comparing, we need to find out the differences. Difference कसा येईल आपल्याला? Difference is nothing but the subtraction. ओके, दोन्ही ग्रुप आपल्याला समजा एक ग्रुप दुसऱ्याशी कंपेअर करायचा आहे. सो वी नीड टू फाइंड आउट सम डिफरन्सेस while subtracting. So that's the reason here degree of freedom. Okay, here you can see the degree of freedom is 2. So why 2 is there? Because number of groups are 3. So 3 minus 1 is the 2. So at a time we are comparing one group to two group only. Okay, suppose group number G1 and G2 will be compared. G2 and G3 will be compared. G3 and G1 will be compared. Okay, so here degree of freedom is that number of groups minus 1, right? Another thing is that, okay, I'll scroll it down. Mean square. The mean squares are the key terms in classical ANOVA. They are variances calculated by dividing the between and within the group sum of squares by the appropriate number of degrees of freedom. Okay, means what? Sum of squares and degrees of freedom ह्या दोघांवरून आपण what we are calculating mean squares. Okay, see why I'm telling you this is, see these are the actual internal calculations that ANOVA has. Okay, ANOVA while doing the calculations or जेव्हा आपल्याला final result मिळतो, just when we click on one way ANOVA and we click and we are getting the final summary table. But what happens behind the scene is it considers all the values. It considers 3 groups. It considers number of data points in each group. Then it compares each and every group. So for comparing, it takes only 2 group at the time. So that it takes k-1. Okay, it takes n-1 for the within the group comparison. And when we are doing within the group comparison, प्रत्येक डेटा सेट आपल्याला दुसरा डेटा आयटम समजा I am storing the marks of 10 students, right? So each mark will be compared with the another mark within the group. Okay, roll number 1 चे मार्क roll number 2 शी compare होतील. Roll number 1 चे मार्क roll number 3 शी compare होतील. So in that way, it is going to find out the differences. That's the reason it is taking n-1 and that's the reason it is taking k-1, right? Okay, here as in the starting we have seen that ANOVA test is also called as the F test. So F is a factor here. Okay, F stands for the factor here. Factor is nothing but the categorical value. So here F is F value gives the ratio. Okay, what ratio it gives? So whenever we perform ANOVA in Excel, we'll end up with the summary table. So in that summary table, three values are very important: F value, F critical value, and P value. ह्या तीन value वरून we will decide whether to support the null hypothesis or whether to reject the null hypothesis. Okay, so if the F value or factor value is greater than F critical value, we will reject the null hypothesis. Okay, why we are doing this? Like, see, there are some standard test or standard values are set for the ANOVA test. की या व्हॅल्यूच्या खाली जर का एखादी व्हॅल्यू असेल, then we are going to reject the null hypothesis. So how F value is computed? F value is computed by this division, like MSB divided by MSW. Means what? Between the group divided by within the group. Okay, variance of between the group divided by variance of within the group. ह्या दोघांचा जो रेशियो आहे, that is given in the F value. Okay, मीन स्क्वेअरच्या बाजूचा जो कॉलम आहे 1 2 3 4 फिफ्थ जो कॉलम आहे F चा, that F value is very important here. What F value gives us? F value is nothing but the factor value between the groups of variance is divided by within the groups of variable, and what the value we are getting is the F value. Okay, then comes the P value. P value is nothing but the probability value. जर का 0.5 कारण की probability नेहमी 0 आणि 1 च्या मध्ये असते, right? Probability means what? The possibility of happening something. एखादा इव्हेंट येण्याची पॉसिबिलिटी असते, राईट? आज स्टुडंट येईल का नाही, आज टीचर लेक्चर घेणार आहेत का नाही, ओके, वेदर इट इज गोइंग टू रेन टुडे और नॉट. So probability is nothing but the possibility of happening something. So it is always between 0 and 1. So here a P value is considered, standard P value here is considered in between 0 and 1, that is 0.5. मग त्या 0.5 च्या वरती आणि खाली जर का व्हॅल्यू असेल, so depending upon the P value, the null hypothesis will be rejected or supported. So here the P value is greater than or less than 0.5. What we can observe? Look at the P value, it is 0.859494, right? So P value here is greater than 0.5, right? So here null
Yes, ma'am.
hypothesis is rejected and the alternative hypothesis is accepted, obviously. Okay, so see here आपण खूप randomly आणि वेग म्हणजे मी मनाच्या व्हॅल्यूज घेतल्या होत्या इथे. So this summary table is not very standard one. Okay, I have just shown you how to calculate quickly, very easily in the Excel. It is also considered okay if you are considering the research. Means तुम्ही जर का actually research करताना तुमचे values इथे टाकले आणि अशा प्रकारे ANOVA काढले, it is considered okay, म्हणजे तो valid धरला जातो. Only the thing is you need to understand the summary table of ANOVA. Like source of variation कुठून काढले तुम्ही, between the groups and within the group. Then sum of square you have find out. Degree of freedom is taken by n-1 and k-1. n-1 is number of data items minus 1 and number of groups minus 1. Okay, why this? Because we have to compare the between the groups and within the group, so that we have to take minus 1. Then mean square, it is considered mean square from the sum of square and degree of freedom, mean square काढला जातो. Then F, that is factor value, is very important. Factor value is nothing but the ratio of variance between the group divided by variance within the group. From that you are having the factor value. P value is nothing but the probability value. The standard value is 0.5. Depending upon the value, less than 0.5 or greater than 0.5, the null hypothesis will be supported or it will be discarded, and alternative hypothesis will be supported or considered. The last column is F critical value. F critical value is nothing but it is the considered as the highest probability value of the F factor. Okay, so if F value is suppose your F value is greater than F critical value, जर का F ची व्हॅल्यू इथे F critical value पेक्षा जर का ग्रेटर असेल, in that case also the null hypothesis is rejected. पण इथे greater नाहीये. Okay, but here what the p value is, what p value is also greater than 0.5. Okay, so here we are getting little bit what you call p value and f value वरून ANOVA test's performance ठरतो whether to support or reject the null hypothesis. Okay, but here we have taken data randomly, so the reason is we are getting p value greater and f value smaller. Okay, so this is the ANOVA summary table of the one-way ANOVA. How to consider the two-way ANOVA? It is simple. Just consider the sheet or consider the data that you are taking. Just a second. Okay, consider the same data. Okay, then go to the data analysis tool pack. In the data tab, data analysis tool pack. Here, two-way ANOVA we can have. F-test two samples for variable or two factor with replication. These are, see, in this box you can see ANOVA single factor, ANOVA two factor with replication, ANOVA two factor without replication. So what are these? These are some little bit variations of the ANOVA. Okay, I'm taking the ANOVA in two way. So input range is given, same input range we are giving. Okay, say I have taken the data randomly, so it is overlapping. Okay, so in two-way ANOVA, you need to have the more groups or two independent variables, and just go on selecting the like we have selected in the one-way ANOVA, and simply see it in many data analysis tool pack, depending upon the version. See, in my laptop version, it is only showing single factor ANOVA. But in some versions you can याच्या खाली तुम्ही हे पण बघू शकता की ANOVA two way or double factor ANOVA. Okay, so depending upon the version also you will see the number of tests here. Okay, also you can see here descriptive analysis statistic test, inferential statistics test, which are not listed in this version here, right? So doing the ANOVA test in Excel is very simple. At very few clicks you can have this, right? One more last point I will tell. See, clear difference between one-way and two-way ANOVA is definition is a test that allows one to make comparisons between the means of three or more groups of data, and two-way ANOVA, the test that allows one to make comparisons between the means of three or more groups of data where two independent variables are considered. So number of independent variables इथे महत्वाचं आहे की वन वे मध्ये वन असतात इंडिपेंडेंट व्हेरिएबल, म्हणजे इनपुट व्हेरिएबल. इंडिपेंडेंट व्हेरिएबल इज ऑलवेज इनपुट व्हेरिएबल, हे लक्षात ठेवा. इनपुट देतो आपण इंडिपेंडेंट व्हेरिएबलनी आणि आउटपुट घेतो आपण डिपेंडेंट व्हेरिएबलनी. ओके, सो इन वन वे मेन डिफरन्स काय, इंडिपेंडेंट इनपुट एकच असतं वन वे ANOVA मध्ये. इन टू वे ANOVA वी आर हॅव्हिंग टू इनपुट्स. ओके, बिकॉज वी आर कन्सिडरिंग टू इंडिपेंडेंट व्हेरिएबल्स हियर. हॅलो.
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, I thought you are looking at my screen. Okay, so independent variable is 1 and 2. That is the main difference. Another is what is being compared actually. So the means of three or more groups of an independent variable on a dependent variable. Then the effect of multiple groups of two independent variable, that is being compared actually. Number of groups of samples. Who is doing that? I think somebody is doing something on the screen. Number of groups of samples, three or more. Number of groups of sample in two-way ANOVA is each variable should have multiple samples. Okay, so this is clear-cut difference. So final point is that depending upon the p-value, the null hypothesis will be accepted or rejected. So what will be the value? It should be standard value is 0.5. Okay, so if it is less than 0.5 p-value, the null hypothesis will be rejected. If it is greater than 0.5, it will be supported. Okay. So that is all about the ANOVA here. You can have a couple of, if you want to have any doubts, 1 or 2 minutes we can talk. See, I will recommend that whenever you are considering some data in your research, correct that data, make the data in the groups, and ANOVA test is highly recommended because being PhD candidate, you will be taking large amount of data which is observed from for over the period of time. So ANOVA test will be very useful for you to do some prediction or to reach to some conclusions. Okay. If you can, if you feel any like queries or problem, you can contact me always. Okay. So shall we stop here? If there are no queries, I hope ANOVA test some overview or little bit knowledge of ANOVA today you have got. Is it okay?
Yes, madam.
Yes, ma'am.
Okay. So thank you so much for your patience listening, and sorry for the disturbance that took place in between.
No problem.
I am thankful to Dr. Kaveri Lad Madam and to the HRDC MMPC for giving me the opportunity. If you are having any queries while actually doing the survey and conducting the ANOVA, I'll be happy if you find me useful to solve your problems. Thank you.
Thank you, ma'am.
Thank you, ma'am.
As Mansi ma'am introduced us about ANOVA test, ma'am covered hypothesis testing and the relation between ANOVA and hypothesis testing with examples in MS Excel. On behalf of HRDC, I would like to conclude this session by showing heartfelt gratitude to Mansi ma'am for your guidance. I will conclude that session is over. Thank you. Thank you, ma'am.
Okay, thank you so much.
There will be a break for 15 minutes. Huh?
Okay, ma'am. Okay, ma'am.